Hey guys, this is Mrs. Tran-Bloom. We are starting our new unit here. So 3.1 says derivative of a function. So our first definition is the average rate of change. This is indeed a review of last unit, okay? So the average rate of change is when 2 points are known. Now, if you guys remember last unit, aka this was also thought of as a slope of a secant line. So the formula of this slope is the change in y divided by the change in x. And last unit, we were using f of b minus f of a divided by b minus a. Or in Algebra 1, it is okay to go y2 minus y1 all over x2 minus x1. Any one of those is okay by me. Now, we also talked about the definition of instantaneous rate of change. Now, remember, the instantaneous rate of change is when 1 point is known. Well, so how do you find the slope when 1 point is known? This is, remember, we talked about this. This is when looking at the graph of the function, is the slope of the tangent or tangent line, because in your book sometimes they said find the tangent, which is the same thing as find the tangent line. Okay, so tangent line at a point known, let's call it A, and the y value would obviously f of a, and a nearby point. Let's say that we don't know where that is, so we will give it an unknown x. So that means its y value will be f of x. Okay, so we have 2 points here. We are going to have 1 point that's given to us. And remember, we talked about, hey, let's pick a nearby point. Let's call it whatever, x, comma, f of x. Now, last unit, okay, so last unit, you were given a formula. The limit as h approaches 0 of f of the known point a plus h minus f of a, whatever that algebra 1 value may be, divided by h, and we talked about h is the distance, right, from a, or to a, however you want to think of it. Okay. Now, this unit, we are going to add a similar formula. So, new formula. We are going to use the limit as our nearby point, which is x, approaches our given point, which is a. So if our nearby point is approaching our given point, then obviously the closer the point we pick, right, if it approaches our given point, then the distance would be very minimal. So the concept is still the same. And so because we're picking, I mean the y value will be f of x minus f of a all over x minus a. Okay, so this means the point we picked, which is x comma f of x, okay, is approaching the given point a comma f of a. All right. Now, this in calculus, guys, is referred to as the derivative. Okay. And notation, guys, so we do have the notation to the derivative. Okay, so the notation is f, and then there's this prime of a. I'm going to spell it out. Ready? This is red. This is red. F prime of a, or derivative of f at, ooh, that's too close together, at point A. Okay. All right, formal definition of the derivative. This is used to find the derivative of f as a completely separate function. Okay, so here we go. The derivative of the function f with respect to the variable x is the function f prime whose variable x is, ready? F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. We have seen that before, would you agree? Provides that the limit exists. Now the domain of f prime is in the domain of f, which means, guys, the domain of f prime, the domain of f prime may be smaller than domain of f. Okay. Now let's go back and do, how about this? Can we do a bullet right? Oh my goodness, what happened? Okay, can we do a bullet right here? That's number one. Number two will be the domain, and then one more bullet right there. Okay. If f prime of x exists, we say that f is differentiable at x. So this is a word that we want to know. So a couple highlights here, guys. The formal definition of the derivative. You have to know this definition. Okay, it doesn't go away at all, ever. So make sure this is highlighted. It is the same exact formula as last unit. And then we do want to know the domain of f prime. It's in the domain of f, which may be smaller than the domain of f itself. Okay. Now, if f prime exists, then we say it's differentiable at x. Another definition for derivative. This is a second definition or an alternative definition. The formal definition you must know. There's no ifs, ands, or buts about it, okay? Now, sometimes it is easier to use this alternative definition here. And in your book, it will state use the other definition of derivative or use a formal. So make sure you guys read those directions very carefully. All right, so the second definition of derivative. derivative of f at a point, let's call it a, is f prime of a equals the limit as x approaches a of f of x minus f of a all over x minus a, provides that the limit exists. Okay, now students, use this formula. Use this when you know the point. Okay, use the formal definition when you don't know the point.